Uh, it's up now, but I lost my train of thought. Uh, yeah, pretty much anyone who wants to participate and even hop in voice and solve problems is welcome to. You're Ron Dick. Okay. I sent it to you, just joined. I'm in streamers, so I can't quite see usernames, but I'm just gonna give you the role and hope for the best. Reading group VC. And so you should be able to now see or be able to join like that reading group voice chat. That's where we'll be meeting. Oh, awesome, Plum. Thanks for letting me know. I was having an issue where like after like an hour or something, it would randomly become choppy. So hopefully it stays good. There's something else I wanted to say. I think it's about grad school. Oh yeah, so no, I lost it again. Dude, why is my mind like this? Oh yeah, okay, so I'm trying to I'd like to do their internal application to go on or like to stay with them for a PhD. And so a way you can do that to stand out is to take the PhD level courses rather than the master level courses. And so I want to succeed in the PhD level complex analysis class that will be in the first quarter. So that's why don't do it. Too late, Jasu. I've also wanted to do it for a very long time. It's going to be hard to dissuade me. Is that why is that why you're gonna go back for bachelor's? Is that just like more fun? Okay, I think it's everything I wanted to announce. So yeah, I guess let's get into it. What got me into math? Basically, in senior year of high school, I took my first calculus class, and I made the connection without ever being like taught it that like but between like what I was learning in calculus class and what I was learning about in my physics class. So like um in a regular physics class, it's pretty common for you to learn about like the equations for the motion of a projectile. Like if you just throw a ball, it follows that like parabola, and you can find where it is at any point in time with equations. Like if this is the height of it, like your starting height plus your initial velocity times sine of the angle theta times time plus 1/2, I guess minus half times gravity squared. Gravity times time squared. And then there's also an equation for the velocity at any time, which is e naught sine theta minus gt. And then there's also one for acceleration, which is minus g. It's like these, like if you don't remember these in particular, this doesn't make sense to you. It's fine. It's not important. But basically, you get taught these three equations as separate things that you just have to memorize that represent the path of a ball as you throw it through the air. And then in calculus, you learn these things are actually interconnected, and you can start, if you know just one of these equations, you can figure out what the other two must be if you know calculus, and making that connection was a really cool thing. Secret Agent Wolf, hello, welcome in. It's good to have you here. Our error high? Yeah, like I was like, oh, like math is actually kind of cool. Like it's useful. Like I found out to the point where I'm learning math that feels kind of useful for things. You might be a masochist, Jasu. for first 2 years of prep. Sure, with math at school, that have a teacher like you. Oh, well, thanks. Yeah, I try to make it approachable. There's definitely people who intentionally make math difficult to understand because they think it should be that way. But there's a whole niche of math streamers here on Twitch that try to make math more digestible for people, and like find the as fun of a part as you can find. You know, that if people, not everyone has to like math and not everyone will like math, but hopefully at least find some little section of it that people think is interesting, even if they still don't like math overall. Reading writes was a go-to. Fair enough, yeah. I'm kind of the opposite. Like I did well enough in my English classes, but I did not enjoy them. I stopped reading the books after like junior year and just used SparkNotes for everything. I still did. I still got like a 5 on the AP English exam though, just using SparkNotes. So wind bikes and line integrals. I think we should get to some shout outs in order here. First off, to Academy's ideas for the raid earlier, who's an awesome math streamer. And then to the kind of like my general math streamers thing, of which E2Y Zach is here right now. And then Plum is a good friend. He plays Daisy, so it feels a little bit weird to shout out Daisy when math is happening, but Plum's a cool dude, and if you like Daisy, you should check him out. I bet we could bully / convince Matthew to do another stream if people show enough interest. Because Matthew has done at least one stream about the Riemann hypothesis, and so it's always good to have more people stream in math than not. No worries. No time to do in school. If that's interesting, you listen. Yeah, like the teacher can really make or break the class, even if it's not something that's super interesting. Bully Matthew, I'm on it. Singular homology? Okay, nice. I can't say I know what that is, but like I would definitely like take a look at it and try. Got my ass kicked in French and swapped to English. Okay. I left off on number 7 is the next one. So yeah, the way these streams go is I take questions from chat and do my best to answer them. If there aren't questions from chat at the time, though, then I do some studying, and today I'm choosing to do a little bit of physics for the downtime here. So we're doing some rotational stuff in this chapter. Hey, Mate. Math teachers weren't fun. Yeah, I had some okay math teachers. I wouldn't say I feel like I've had maybe 1 or 2 great math teachers ever. Yeah, I think for most people the want to study math kind of has to come from within, because like usually teachers aren't doing it a favor as a subject, and that's not always their fault. Like they have to teach a certain curriculum, sometimes they have to teach it a certain way. No worries, Secret Agent Wolf. Appreciate you popping in. I hope your day goes well. You didn't like she was a new math teacher. She didn't even know the material she was on. Failed the test because lack of information wasn't received. Oh no! Oh, that's terrible. Yeah, that's a bad situation all around. I had maybe like the worst teacher I've had was in like I think it was fifth grade. She was only there for 2 years. And like she was good enough at the actual act of teaching, but she kept on like I didn't know at the time, but she was apparently like showing up to work like hungover. Like we did watch a lot of movies in that class. And I had her for her first year there. The second year, when she knew she was about to get fired, she apparently had students like load up her car with the school's computers and stuff because she was going to try and just drive away with them and steal them, I guess. She got caught in the act. But like, yeah, that's probably the worst teacher. Um, yeah. To be honest, as a kid, I don't remember her being that bad. I kind of like heard about how bad she is after. Chambers over in the YouTube chat is asking, oh God, something that I am probably gonna struggle with. Chemistry by a mathematician. The final year got to teach a PhD in organic chemistry. I mean, chemistry by a mathematician could be a cool angle. Pun intended. Yeah. I never took the class in it, but organic chem seems like the the really hard class in chem, from what I've heard. So we have a right triangle. If they're an arithmetic progression, isn't that just 3, 4, 5? Oh, I mean a scalar multiple of 3, 4, 5. Oh no, not necessarily. Approaches are fundamentally different. Yeah, that will make sense. Okay, so let's say the smallest side is S. And then I guess that can be like we can do D for difference like Jess was saying, and then S plus 2D. 2D. Sounds weird. And France chemistry is taught in a fucked up way, so traumatic. Ugh. My second, so I did 2 semesters of chemistry, and you take a chemistry lecture class and a chemistry lab class. And in my second semester, the teacher or the professor for the lab was this French lady who was just a terrible teacher. Like she basically bullied me. And like there's an odd number of people in the class, and most of the labs you have to do them in pairs. She would specifically single me out to be the only person to do it alone and would not let me like make a 3-person group. And I can like normally I really like French accents, and I still do like pretty much every French accent I hear, but hers, probably because of that, it's like the most annoying thing. Central, thank you. I've been really bad about shouting you out since you came back, but Central's just recently come back to stream in DayZ, so everyone's here on the DayZ end of things. Central's back at it. Just need to combine Pythagorean theorem and area. Okay, yeah. Pythagorean theorem is not a good idea. Well, I want to, Central. Physical chemistry? Yeah, I've heard that like a separate class, but not as like a philosophy to teach all of chemistry through. You got it from here? Chambers. Yeah, I think this is it's two unknowns and two equations, so we can solve the entire thing now. If you're fine from here, then great. I want to solve it just for my own interest, but feel free to, tune out or do your own thing if you want. I'm just kind of to see what the answer is here. So I'm going to multiply out that bottom equation. We have s squared plus 4ds plus 4d squared. S squared plus 2. I don't remember the Nintendo DS. That thing slapped. D squared plus S squared. So we get 0 is S squared minus 2ds minus 3d squared. Okay, yeah. I think at this point, we can't really isolate S or D with this, can we? So I should work with this equation and isolate D. That's funny. I wonder if you had a system of two quadratic equations with two unknowns, there must be a way of solving that. I probably shouldn't ask questions I don't want to know the answer to because it's probably painful. But if you had x squared plus 2xy minus 3y squared equals 5 and minus x squared plus 3xy minus... Making random numbers is so hard. Is equal to 2. Surely you can solve that for x and y. I don't know how. Complete the square. Oh, okay. Yeah, that's probably it. Paper's like a flashbang. Good. I'm a champion of light mode. Light mode until I die. Matei saying the answer is 6? Okay. Papadoria, it's Fundamental Theorem of Calculus Part 2 defined for A, B, part of the complex set. Oh. Content on the paper. Oh, okay. Well, it can be both. I'll put that up on the screen, Papadoria. I want to follow these calculations through. But you do ask an interesting question. I would assume it is. It feels like the type of thing that would be. Yeah, if anyone wants to start thinking about that and helping me out, so I'm not going to know that an answer to this for certain, so. S squared plus SD. And so we get D equals 48 minus S squared over S. Okay, this is getting tedious. I should have just made Wolfram Alpha solve this if I was like curious about it. But we now have oh, I'm eliminating. Okay, no, it's good to eliminate D. So we want S. Okay, I'm not solving it from here because this is getting annoying now. But you can, in theory, isolate S here and solve it. I guess it's going to be a cubic, which is unfortunate, or a quartic even. Arithmetic sequence. But yeah, that's how we found the sides of the triangle, right? Basically, do your homeworks. Basically it. If one person starts asking too many questions, then I'll like tell them they gotta cool it down. But yeah, I mean the goal of stream is to be a homework help. like stream. So, hey Cytos. Like, just like doing challenging math problems for its own sake it's not my thing. Speaking of the devil, there's a Yush calling me a noob for not doing competition math. Okay, I'm gonna leave this problem here because I don't feel like solving that. Let's think about Papadoria's question. So like, I assume like Papadoria's is even asking something like, what if you had the interval from -I to 2I of just some normal function? Thank you, syntax. I assume you can do this. I don't see why not. Hey, Aikido. Actually, oh, maybe there's a reason why not. I don't know what this means. X is gonna have to be a complex number, I assume, and I think we're just gonna have to be fully in complex. Like, normally when you do an integral, we're talking about a function that maps R to R. I assume we're gonna have to talk about functions that map C to C. All right, Plum. Thanks for popping in and saying hi. Hope you have a good day. And thank you as well for the well wishes. Can be up to define what path you follow, but Cauchy formula tells you integrals not depend on path you choose for homomorphic functions. Okay. Just released a new pope. New pope just dropped. Some influence my usage of Leibniz's rule differentiating under the integral sign. You have to throw it out completely now. The new pope does have a bachelor's in math. To be integrable as Riemann, the function needs to be continuous. You say it's not integrable if it's the real sinus. Interesting. Yeah, I think it's a good point, Aikido. And I'm saying I think because I'm out of my depth here, so I don't know anything. But I think if this is a Riemann integral, this makes no sense. Or at least not without doing something to the inside. Like my specific example of sine of x might be bad. Yeah, a new pope just dropped. He's apparently American and has a bachelor's in math. For complex differentials, you guys have been doing force to calc. You actually don't know what a complex integral is. Me neither, and I'm hopefully learning about that very soon. How to convert to PhD. I got a real number for your sine integral. What's that, Cytos? It's JE Advanced Chanverse. Oh, to be honest, for JE Advanced, this feels a little bit tame. Sorry, yeah, I'm sorry. If you want to see, if it'll help you see this all the way through, I will go and solve it. I just assume that you already knew what to do from here. But if it would help you to see that, I can do it. I was just getting lazy. What is that, Cytos? Does that simplify to something? Oh, is there some crazy relationship between E and pi, maybe? Essentially taking the imaginary bounds of a Riemann integral has no good meaning. I think so, Papadoria. I don't know enough about complex numbers to know how it works. I do have, like, I am just starting to go through this book here, and it is posted in my Discord, and in the complex analysis thing. So if you do want a resource to like look through about complex integration, you could try that book. I just don't even it's even in chapter 2 where they start talking about integrals. I just don't know enough about it to like have a good comment. But yeah, I think like the Riemann meaning of an integral could make sense, but you need to do it in a certain way for it to make sense. Is what I imagine the answer is. The way that I've written it there probably just doesn't make sense without some better context. And I guess there's a complication where I think that the biggest complication is that, oh no, it's all stretchy. Is that complex numbers are like two-dimensional. And so if you want to integrate from, say, like the point -1 minus I to the point 3 plus I, that's like a two-dimensional path. And so you get and there's many different ways of connecting these two things to make it even worse. It's not as simple as just a regular single variable Riemann integral. It could be like a multiple Riemann integral in some way, or it could be something more complicated. It's still Riemann, but like in multivariable, I don't know if you've taken a multivariable calculus class. I assume you have, but you know you have to worry about like paths here. And I think Matthew said earlier that for a lot of functions the path doesn't matter. But I think there's a lot of multivariable calculus involved in complex numbers because of that two-dimensional aspect to complex numbers. Okay, you have taken a multivariate calculus. It's all going to be based on the real integration, I think, as we've learned it normally. Just some things are going to look a little bit different, I think. Or also told me my answer is wrong, but the answer is real. I assume that simplifies in some way then, Silas. I really don't see what it would be though. Complex integration is different from normal integration. Yeah, as far as I know. The path integral, you need a path to define it? Okay. If you need some course to catch up, I'd be glad to help. Oh, nice. Do you drop a negative sign? Oh, fair enough, Cytos. Try to find sign by its series, then justify the integral set. Oh, yeah, maybe you can do some series thing on that sign. We do integrate bounds with paths, right? Contour integration, Cytos? Okay, so I just realized this from watching Zach's stream an hour or two ago, but I think contour integration and path integration are slightly different. Let me make sure that I'm not spouting crap here. I need Paul. Well, yeah. Get Paul on the phone. Oh, actually, I don't know if Paul's going to do this. I don't know anymore. I think I'm getting my interpretation of integrals mixed up right now, to be honest. Because isn't maybe it's the same thing. No, I don't remember anymore. I can't give you a good answer. I was thinking there's thank you, Fenbox. Isn't there a this might just be the same exact thing as a line integral. But if you have some surface, I should do a different color. You could integrate along a path on that surface and get the area from that surface along that path down to the XY plane. And I would always think that it's like dropping a curtain down, and this is your curtain rod. And you're getting the surface area of that. Is that the same thing as a line integral, or is that a different thing? That's what I'm getting confused about. I think Feynman created something in quantum physics that uses an infinite amount of paths for an integral. I think I've heard of that, like the sum of histories thing as a concept. You think it's a little bit different than a line integral? Okay. Yeah, my multivariable calc knowledge is frustratingly spotty. Oh yeah. Contour path integral in the complex plane, it might be. How long have I been an affiliate for? 2 years. Yeah, 2 years. I started streaming 2 years and a couple months ago. It was in January. Who dropped a paper in R3? Why is a centipede on it? All the best math is done with centipedes. No, dude, it's a bit of a dickhead. I've heard the same. But yeah, like the math community has evolved in such a cool way in the 2 years that I've been doing this. If your domain is simply connected, path doesn't matter. If your domain is, say, C minus 0, then all paths are not equivalent. You see that integrals depend on path. Interesting. We were kind of... Colin was actually just telling me about how like the domain can affect whether the path matters. Boom, 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 boom. 7 streak, thank you. But yeah, so I'm getting my terminology mixed up. I can't remember if this type of integral is different from a regular line integral, which I think of at least now as a line integral. Instead of a surface, you have a vector field, I guess. And you're moving through that vector field. But I don't know if that's comes out to be the same thing or not, to be honest. So that's where I'm getting confused. So there's your terrible answer to your question, Papadoria. The reason for the public reason for divorce, he was doing too much calculus, which would have been fire. Oh, yeah. I much prefer the too much calculus explanation. Sounds good, Papadoria. Okay. Crash the whip because I was integrating. Don't drink and derive. Okay, let me make sure there's not any questions in the Discord or anything. I think we're good. So let's go back to doing the physics until someone else pops in with one. Oh, I see someone. I just got a ping on Discord. Let's see. Oh God, from Krim. Are you just? Oh wait. Oh, E&M. Ah, you know my weakness, Krim. I didn't even see that. I can delete the VOD. I can turn off my stream and delete that if you don't want that out there. Okay. Awkward. Uh, drink and derive anything. Okay, and so while you're focusing on not doxing yourself, let me bring up my E&M book and look at Ampere's law again. Where is it? Ampere's law, was that? We should just do Control F. I don't remember what chapter it would be. Ampere's law is a line integral related to the magnetic field. Aha! Drink and differentiate. Yeah, the community here is pretty cool. Um, Wait, isn't this oh wait, no. Ampere's law involves an integral. This is chapter 6. Let me get it written out. Aha! The electric field integrated around a path is equal to mu times the current enclosed by the path. Okay. It is valid for steady currents. Since again, without doxing yourself. Great. I see your solution to not doxing yourself. Okay. Let me just take a screenshot of your Discord thing. Looking at the Poisson equation for modeling membrane transmembrane potential. Oh, like the Poisson equation involving the Laplacian of a function, I think equals 0. I forget, like maybe at f or something there. Isn't like that Poisson equation? I don't remember if it's equal to 0 or equal to something else. Like I think Poisson's equation equals 0. Conductor concurrent ion form semicircle AB. Okay, so this is our wire here. Find the magnitude of... Are these minus signs? Like... Or maybe it's just b dot dl and I shouldn't overthink it. For the circle, x squared plus z squared equals 3r squared. In the xz plane, due to current in the curve AB. Yeah, like it's a little bit weird to enclose it like this because the circle is centered on the origin, but the current is passing through like, r comma 0 comma 0. But I don't think that would matter for Ampere's law. Correct answer given. Oh, I have 2. Ooh. Interesting. Because it shouldn't be any different from like a straight wire, I would think. Like you just connect A to B with a straight line, and theoretically it should be the same, but maybe it's not for some reason. No, it does, the path doesn't matter. Yeah, Matthew, I was thinking about that too, that the path isn't closed. I assume we're just neglecting that, and the wire actually extends somewhere else that we just don't care about. That's how I'm squaring that in my head. Applying Ampere's... Oh, Ren, my hero. Applying Ampere's the way most people apply it requires symmetry of the current. Really? I hope you're doing well by it, by the way, Ren. It's been a minute. Um, how long, almost over? As in like grad school? If so, good. Oh, nice. Well, congratulations. Hey, Carl. Oh, you're Sage. Okay. Good luck with your math tutoring. Last month's reading before grad school. I I was looking at a past syllabus for that complex analysis class, and it said there's weekly homework assignments that will test your stamina and your peaceful nature. And like, man, is it seriously that intense? I believe that the answer is yes, but like, I don't know. That just seems like I feel like if they're saying that, then they're just intentionally like gatekeeping, I guess. First hearing to long off for so long. Oh, nice. Nikhil's asking about the polar position of a complex number. Yeah, we can talk about that. I'm hoping to answer a question from Krim first, but you'll be right after. Fair enough, Matthew. By enclosed path. Yeah, so Ren is saying that we need symmetry for how most people use Ampere's law. Introduce the path integral to b times the length of the curve. Otherwise, you have to actually do the path integral. I mean, I'm getting stupid here. What? This wire would make magnetic fields, I guess, close enough to the wire, are growing in circles with the wire in their center. Far enough away, it gets a little bit sketchier, but we want the magnitude of the path integral around that path. Infinite wire works so because B feels symmetrical for radius r around the circular loop. And so, yeah, I guess here, B is definitely not symmetric around this loop. Um, but isn't it still enclosing current? Like, or isn't the current enclosed still this, like, it's just, we're only enclosing that little bit of current right there, right? What the hell? Like, it still seems weird that it wouldn't be mu naught I. If it's mu naught I over 2, I assume there's something we should think about the completed circle in some way, and that would be mu naught I. I I don't know why this half circle. But like, this is the magnitude of B, the magnetic field, dot dl. Uh, Ampere's law always works for steady currents, but the way you want to apply it is using symmetry, so you don't have to do the integral. So it is equal to mu I. So enclosed current, if in the simple case of like an infinite wire, like Ren is saying, if that's your wire that goes out to infinity, and has current running through it, you would draw a two-dimensional circle that's like a cross section, and the enclosed current is whatever current is going through that cross section. Like you've heard of like I think it's basically the same thing as like J vector. That's like the amount of charge dotted with dA. I think it's basically the same thing. But that's what I mean by enclosed current. Like you have to draw that two-dimensional surface that thing's pass through, I think. Yeah. Uh, I think Matthew, or like I think what Matthew is saying, it sounds right to me where we need to think about the full circle, but this is enclosing two currents. So I don't quite. I don't quite know what to do with that. Oh, wait. No, wait. Yes? I'm thinking about. This is root 3R. That's annoying. If the circle was. Well, Weird shaped conductors like the semicircle. I think the answer is that we do need to consider a full circle that's nice and symmetric, and we're going to cut it in half. But I can't figure out why the full circle would be mu naught I. But I think the idea has to be like we're using superposition where the full circle is two half circles. So we figured out for the full circle, and then we cut it in half. Whatever the result is. I was hoping that the circle would be smaller, or like that. I was hoping that the circle would go outside of the path. But the scales here don't quite work out. That's root 3R and that's just R. Because I think if the circle went outside, then it seems more obvious to me. Hey, positive Pete. How many numbers of pi do I know? 3.141592. That's all that I know. I know that N simplex Pachinko can name quite a few of them off the top of his head. You know 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. True. You just know them all, Zach. Classic combination versus permutation. But yeah, welcome in, Positive Pete. Glad to have you. Jed. A, B, C, D, E, F. Oh man, the real simple answer is that you know 0 and 1, but you're a programmer. We're enclosing two currents. 92 magnetic flux. I mean, that's kind of what we're figuring out, Nikhil. Programming hexadecimal binaries for babies. Okay. Nikhil, Ampere's law says that this line integral is equal to mu naught times the enclosed current. But the meaning of enclosed current is a little bit weird here. The full circle magnetic field is the sum of the two halves. The express of the left half circle is related to the other half. Or the 50-50 for the full circle. But the issue that I have is that this loop encloses 2I. So I'm back to the original thing of saying just the right circle would enclose, or will be just I. But the answer is, and when I say I mean mu times I. But the answer is apparently mu naught I over 2. And that I don't get. You just picked electrostatic to Bcos. Oh, fair enough. Yeah, this is magnetism, so it's gonna be a little bit difficult. Banach-Tarski, I feel like I've heard of that. I don't know if I can explain it. Oh, I've looked at this before. I bet someone in chat would know about this. I don't think I can though. I saw a video that involved this. Yeah, it was a Veritasium video. Let me find it. I think of there's a Veritasium video that briefly explains it. It's not the main focus of it. But I think he goes over it. I think it's this one here. And at some point, I want to say he at least mentions the paradox. Yeah, it should be right here. Or it's somewhere around there. Yeah, Banach-Tarski. Actually, you might want to start at. You might want to go to the start of timestamp there. But yeah, I don't know this well enough to explain it for myself. I think, unfortunately. Sorry. Respect to pi digits. So the bar to a mathematician. The name multiplication pi is 0, 1, 2, 3, 5. You said that. Axiom of choice, yeah. Explain the Mandelbrot set. The more it stays the same. Honestly, I never actually looked at the Mandelbrot set. Nikhil. Oh, shoot. Okay, I'm sorry, Nikhil. I was supposed to say that. I'm going to skip and get to your question, but if you have to leave it anyway, that's my bad. Next time I'll try and get to you right away. I've heard of them in the same picture. I don't know what they actually what they actually are. I read the solution given and got it. We need to complete the semicircle and make it a half circle. Now the net current encloses 0. Oh. That's not what I was expecting. So we're not making it a full circle. We're completing it that way. The net current enclosed is 0, which means that the bit through there is equal and opposite to the bit through there. And that's symmetric now. No worries, Krim. Okay, I don't see you getting doxxed in this, so I'll show it. But I'm gonna delay it in case you say no. uh oh. Okay. There it goes. Okay, so this comes from uh just trying to catch up with this piece. That means b times 2 pi times the radius is equal to mu naught I. Manicular due to a straight wire. I made a mistake with this. I was wondering where the extra one, factor 1/2 comes, and I remember there's some subtlety with Ampere's law. But okay, yeah, we can just go straight to saying that's the field of a straight wire. Symmetry, yes, there is no music on YouTube on purpose, because YouTube, if you break copyright on YouTube, they send a hitman after you and your entire family. So I just have the music play on Twitch because I can make it not saved in the VOD, and then YouTube doesn't have something like that, so YouTube just gets no music. But I also don't mind that because I think some people don't like the music, so there's at least an option. What's going on with all the trig stuff? What? Oh my god. They do, Jiasu. Interesting. Okay, so you just that's so annoying. It's just a straight wire, and they're just being obtuse about it. Okay. Fair enough, Krim. Sorry I couldn't actually solve that, but I appreciate you showing me the solution. It's 5 weeks in the hole. It is $10. After you spend all that time studying this, followed by a pill for the service, nothing comes for free. It costs money to break kneecaps. Okay, Cytos, find the volume of a tesseract? Or I don't know that, no, that's not even a tesseract. Or I don't know, the perspective is all weird with that. Okay, it's an interesting question, Grim. Yeah, with the Bios la. But I want to remember, like, so this book makes a point of it being really easy to make a mistake using Ampere's law to find the current, or to find the magnetic field from a wire. And I remember, like, why? Just playing an old Nintendo video game in 2025. It's not saying it. Man, this stuff is so cool. It's just so easy to forget it. I don't remember where exactly they showed that trick question. The exercises of this book are so worthless. Oh, I love this book. No, that hasn't been my experience with it. At least I'm not that good with physics, but like I love this book. Computer guy, hey, hope you're doing well. Yeah, it is Morin. Chapter 5 of Hartle may be where the wheels come off the apple cart. Fembox, I've read through it. It is so hard, though. This is going to be a struggle. I'm feeling nervous about it, too. Because it's brutal. The E&M felt hard, but I never felt like it was as hard as the general. I mean, we haven't even gotten to actual general relativity yet. It's just special relativity, and it's still brutal. I don't know why I'm just randomly scrolling around this. I should actually be doing something right now, right? Uh, okay. I guess should we do mechanics then? It's okay. You're a stormtrooper. So reading a longer book on special relativity by Hellowell. Facing pressure. Oh, nice. Yeah, I mean, like it. The group is ours to set the pace, so we can slow down on chapter 5, or maybe Bizbuzz and Dr. Cook will really come like help us out with explanations if they hop on. Capacitor, ooh. So I'm looking at number 7.7 here. Oh, spherical capacitor, ooh. See you soon, $10. Long simultaneous release from rest at the same height on an inclined plane. And if none of the wheels slip, which one will reach the bottom first? Assume that darker regions indicate higher densities. Ooh. Not all the masses are the same? Do they tell us that? No, okay. How would we think about this? Well, wait. Isn't this just gravity? It accelerates everything equally. Unless there... I think these should all be the same. But maybe it's not. There is none of the above. How would we think about this? We should all be the same except different. Yeah. Hey, dues? I don't know how to say that, but hello. Who made the SI units? I don't know. Isn't that like a UN thing? Like a collaboration of a bunch of people? Maybe it's not even the UN. I don't know. Kinetic energy? Should I be thinking about kinetic energy? Am I doing alone here? Right now I'm just doing some physics studying. While we see if someone pops in with like a math question. Hey, Sarthak. I'm thinking about number 7. For me, it's nearly 2:30 in the afternoon. Miyoko, oh gosh, I'll check it. Oh god. I guess this is doable. This is a bunch of calculations, though. Alright, see you, dudes. It's 3 at night? Jeez. Miyoko, this is a painful question. This is definitely a binomial expansion question. Um, a funny joke is math related. Oh, I would love to hear it. Skeleton first. You got it. I don't know the fractions x over c, y over c, and z over c are all in Europe. How? They're all overseas? Oh my god. That's a freaking dad joke right there. Ugh. Okay, so I don't know what they mean by fourth term. That's kind of the issue. So in the binomial expansion formula, that would be k equals 3 because we're starting counting from 0. But you can flip the order of x and y and get what would be the eighth or the fifth term. Or like k equals 5. Going to work on the bottom Larkin. All right. Thanks for the joke and for the work. So I'm going to assume that they want us to find 8 choose 3 times the first thing cubed, and I might be wrong. Times. Okay, yeah. So I'm gonna trust. Oh wait, no, this is from. Wait, no, it's from Miyoko. Yeah. So Sarthak, it like the exponents could also be the other way around, and that's the part that makes this really weird. Um. Also, these logs are just stupid. Oh wait, it's 5 to the power of log base 5? What's the point of even writing that? What? What a weird question. So these exponents could be swapped around is the real issue here. And so that's where I could just get the wrong answer and it wouldn't necessarily like be anyone's fault. Oh god, Matthew. I don't know if I know how to do those that type of question. The mass of all wheels the same. The answer comes out to be darker center and lighter outside. Really, Kryn? Yeah, so I think there's an error to Miyoko. But this is the setup where the exponents may or may not switch. And from there, you would have to suffer through these calculations. So like, and so since there is an error in the question, I think maybe we won't go all the way through it. I think so too, Krim. But the key thing to know here is that 5 to the log 5 cancels in both of these. I have no clue why you would ever write a question with this in it. But we can immediately get to something that is relatively simpler, but still complicated. They just make you do a bunch of algebra here for no good reason. And so yeah, from there you'd have to go through pain. to actually isolate x here, but it's probably possible. I don't know. Yeah, I think I'm gonna leave the question here, Yoko, because it would feel kind of bad to go through the trouble of isolating x here just to realize they intended the other order of terms. Okay, yeah. But as long as you understand like what you would do here, I think it's the important bit. So thank you for the question. 2 to the x equals t. Yeah, that would help. But it's even easier to just not solve this at all. Okay. Um, so yeah, go. I guess what for looking back at number 7 here, it looks like Krim will be saying the answer is probably C. Um, and so this would have the highest moment of inertia because moment of inertia scales with r squared, right? Um, so that dense part being in the middle is doing a lot of work. I mean, it depends on the exact numbers involved here, but um, that higher moment of inertia gives it higher kinetic energy. Wait. Are we sure it's not reversed? Does rotating make it fall slower or faster? Because if you have a circle that's rolling down an inclined plane, it would start with potential energy mgh, but the kinetic energy gets split up into tangential and rotational. Whereas if you just had a block sliding down a plane, it would be all tangential. So isn't rotating faster worse? Well, but no, it's not slipping. Ugh. The more the kinetic moment is great, the less you accelerate, or the inertia moment. Direct proportional to the moment of inertia in this case. Okay. Hey, welcome in, Meryl Peril. I'm just doing some studying right now. If you have a question, feel free to let me know. So it feels like we want the least moment of inertia. No, feel free to just ask. You can put it there in the YouTube chat, or you can put it in the Discord. And so the one with the least moment of inertia is, I guess, A or D. How do we decide between them? Wait, C has the least moment of inertia? I thought C had the most moment of inertia. Wait. Oh, am I getting the equation mixed up? times r squared. Oh my god. I thought it was divided by r squared. Uh... Oh, you're Nancy. Okay, nice. But shouldn't this have, if they're the same radius, shouldn't that have a lower moment of inertia? Because these aren't all the same, or we're not given they're the same mass. I don't know. Let me look at Nancy's question. The answer is 6, but you don't know how to get there. Ooh, a line integral. All right, we're switching gears for a minute. Number 27, we're asking about. The answer is apparently 6. Compute the line integral of the vector field f over the curve C, writing f as the sum of a gradient and a simpler field. Oh. Really? Yeah, I'm a little weirded out by that part. I I noticed that I assume the way they want us to break this up is like if we took just these parts, that sure as hell looks like the gradient of xyz. What am I writing? And then off to the side here, I'll put the we have a z times j that's left over. I assume that's the simpler field that they're talking about. And oh wait, I copied it down wrong. That's why this won't work. There we go. This thing inside the brackets is the gradient of x, y, z. Technically plus a constant. I assume we don't need that constant for this purpose, though. And so here, I'm just noticing that the x component is missing an x. So it's like we took a partial derivative with respect to x of that thing. The y component is missing a y. The z component is missing a z. So that's what kind of led me to noticing that. Does this, like, I'm sure writing it as the gradient helps us for some reason. I don't know why, though. Does the gradient of a line integral simplify? Sometimes do people take Calc 3? Oh, maybe. It's usually like a third semester thing. Fundamental Theorem of Calculus. Oh. Anime Weeb, you can put it there in chat or in my Discord. Yeah, this is yeah, second year. That's when I did it at least. Um it's asking us to do the line integral. I guess we'd have dx here. It's either the YouTube chat or putting it in the Discord. There's not really another option. And so the dot product, well, let me. The dot product distributes here. Hello, music. I'm not sure. Question from Meryl Peril. So the dot product is distributive here, which is I think what they want us to take advantage of. Because they're giving us x of t. Normally, I'm used to seeing r of t there, but that's why I'm saying x. I don't know if that's right, to be honest. I'm not that strong on this. Hey, animateds. So we're taking the function that's getting gradiented and plugging in terminal minus initial. So we're going to take xyz, as Sarthak is saying, this is x, that's y, that's z, and do pi, t equals pi minus t equals 0. There's probably a better way of expressing this, but that's what's coming to mind at least. Yeah, sure, Meryl Peril. That's probably a little bit better. Trying to explain a solution rather than coming up with it for myself. So I think I'm doing this right, but I'm not representing it in the simplest way. That looks like it's for 29. This is just practice? Okay. G of t equals to f of r of t. Range this function. Yeah, I mean, I didn't want to go straight to the parameterization because of that gradient. Like, they want us to use the gradient. And I assume if we were to make f single variable, the gradient doesn't work anymore? I mean, maybe it still does. Oh, okay. It's from a different edition. I don't think that matches. That's only 2 variables, unfortunately. And we have 3 variables. It doesn't seem like it's the same one. But if I just push through with this, and I can get to 6, that would be nice. And so xyz is the same thing as e t to the 6 times 3t times sine t. And so we would do this evaluated at pi minus that evaluated at 0 for the first integral. Sine of pi is 0. Thank God, so I don't like that. Minus e to the 0 times 3 times 0 times sine of 0. Okay, nice. So that all zeros out as well. So this is what I get from the first integral using Fundamental Theorem of Calculus for line integrals. From this, we know that z is sine of t. And it goes in the j direction or in the y direction, and it's being dotted with the dx vector. So we only really care about the y component of this thing. And not only that, we care about the derivative, I think, because dx is going to be equal to something in the x component times 3 dt times something in the z component. And so I really hope again, there's probably a much cleaner way of writing this than how I'm doing this right now. But at least trying to feel my way through this. The z becomes sine of t. Because of the dot product, we kind of just get to ignore the other components of x and make it just times 3 dt. And now we pray this integral comes out to be 6. And I think it might... Oh, this might be negative 6. No, it might be positive. There's still hope. Sine integrates to negative cosine. Cosine of pi is -1, but then there's negative in front, so it flips around to 1. Minus negative cosine of 0 is +1. Hell yeah. So that becomes +2, so we get 6. So what's the lesson here? It might... So I was intentionally trying to not introduce the t's until the very end, because that it made this step with the fundamental theorem for line integrals easier to see to me. It might have been possible to introduce the t's earlier though. Anyway, you're up next, but I'm kind of in the middle of another question. And Mahanor, yeah, you can ask a question if you want. Um, yeah, I'm sorry. I wish I could do this in a cleaner way, or I wish I could explain it more clearly because I'm not doing a good job of that right now. Okay, I'm glad that part makes sense at least. Um, I was worried that if I immediately made this a function just in t, that the thing with the gradient wouldn't still be true. It might still be true, but it seems more complicated at least. So, all right, sounds good. Thank you for the question. Yeah, I don't know that I've ever done it in this way before. If the instructions didn't say to do that, I would never have thought to try that. Tried it a different way, but it was too long. Yeah, I think trying to figure out the gradient in t seems very difficult if you immediately went to t's. It's a fun question. Like I really enjoy those questions. I just wish that I was better at them. Anime Weave, what the hell is this question? I'll put it on the screen. There's basically zero chance of me solving it. Cal 3 finals upcoming? Oh, nice. Good luck. Like this? I don't know how to do this. uh, unless, like, I guess you'd have to hope this is an integral. Like, it's a hidden Riemann definition. Because it was given by ChatGPT. Yeah, that was in your last test. Are you doing? Is your test the Olympiad? This is not a normal integral people have to do. Change variable at pi over 4 minus t. Find an equation that the integral verifies. I'd rather just not do this. National math. You actually figured out what 0 over 0? Okay, Ashley. Test in 10 days. Good luck with it. I just can't do this though. I'm sorry. What would you find, Ashley? Okay, I haven't addressed Crim's thing for the rings that fall down an inclined slope. Does everyone call everyone bro on chat? I don't know, bro. American fantasy, this kind of integrals? I do not fantasize about these integrals, personally. This is what Crim posted related to problem 7, all the way up here, about which one of these wheels would reach the ground the fastest. Miss or princess? Jasu demands respect. Next they are Yeah, if that summation starting from 1, I think, Sarthak. That's some competition math, anime weave. I don't know the first thing about competition math. From what I've seen of it, I really don't enjoy it. 0/0 is undefined, but 0/0 is an algebra problem for all answers of A divided by B equals C. That seems like that's contradicting what it means to be undefined. If it's assuming A and B are 0, why would it be equal to C if it's undefined? Lady. So Bill Burr says it, and it makes you laugh at every time. It's a reference to something, but I don't know what. I just know how he says it. Is this MAM? Like MAM? Oh, that's probably mass and acceleration. Oh God, syntax. I'm worried, but sure. Oh, that's probably what the reference is. Hey, lady. Oh, that's what you mean, Ashley. Basically, yeah. Madame. Ooh, that's fancy, Jiasu. Or madam. Hit me with its syntax. I'm worried, but I'm increment with what you put here. I'm already not sure what that first line is. Oh, you're doing that. Um, oh man, I've had to do this exact thing before, and it came up with like a differential equations class. How do you do that? Um, it's something weird. LaTeX is better in the Discord, but if you put it in the Twitch chat, I can deal with it. Hmm. All right, enjoy your Naruto, Ashley. Thank you for the update. Yeah, that's what that was about Miyoko and Sarthak. I wasn't quite sure what exactly was happening, but Syntax asking how trying to simplify this apparently. Oh yeah, I mean I was just trying to like render it. If the graph is important, we can do it. Ooh, this is what you're cooking with. My God. This was the sauce. But you're basically trying to get these two things combined into one term. And it'll be a whole lot easier if we just call that A and that B and do that symbolically. Yeah, there's a technique for doing this. Ignore the constant. Okay. I have to remember what it is though. What? That's a specific case though. This is more complicated than I remember it being. From its Aryan good too. It depends what you're trying to do with it. Um, there's nothing you don't know what you're trying to do. I mean, there's nothing wrong with this. If you just want an answer and you don't care about how to get there, I bet Wolfram Alpha would do it. That's not what I want. It seems like this section thread is saying that's not always possible. No, it doesn't. Oh, I guess it's that. So that's it exists. Can't say it doesn't. Save this from typing if you care to have your own copy of that. Yeah, it is weird. Um, Yes, Harthak, I don't know. I think some signs like beta function over gamma. Oh, for like if you're something infinite signs, maybe. I don't think I've ever looked at that. But if you set a sine and a cosine, it makes sense there to be something clean because of the sum and difference identities. Like these things right here feel like there should be something that you can do with them. Which the second change started saying that there is, but it's getting a little bit annoying to try to follow along with it. Okay. So you don't have anything else to ask about that? I guess I'm gonna. I don't know what I'm gonna do. I'm gonna do something. So go back to trying to understand Krim's work. I'm not quite understanding this though, to be honest. Sometimes it's gonna be a rational number because of the 1 minus pi. Huh. I guess so, syntax. Vipov? 2 times 2 plus 2? Well, you do the multiplication first. So 2 times 2 is 4, plus 2. And then 4 plus 2 is 6. The crazy integral guy here? Oh, the person who asked it? I doubt it. They're saying ChatGPT said it was minus a half. It's posted in the Discord though, Krim. If you do want to talk to him about it. Um, it's this thread right here in Math Homework Help. What question, Sarthak? The integral? Or number 7? I don't know what the last one is. 1/2 sine k? Uh, the thing that you got after combining the sine thing was that, but we already looked at that. I don't know if that's what you're talking about. Oh, oh, that might look a little bit bigger. Okay, I know multiple people have explained numbers of it now, but it's still not. All right, I seem to think about it a bit more because it's weird to me that we don't have like even proportions for how things are. So the thing with the highest moment of inertia should get there last. And so that has high moment of inertia, that has high moment of inertia. C is the one that people are saying, yeah. But to me, wouldn't A have a lower moment of inertia than C? Because it's less mass? That's what I'm not getting. It's like I would say A here. You know, I'm just gonna say A, even if everyone else is disagreeing saying C. If I'm wrong, I'm wrong. What's number 8? I'm checking the answers. Once I get through 8, I'm gonna check the answer. Yeah, that's my issue, Krim. They don't tell us that everything has the same mass. If they did have the same mass, I think I would agree that C has less moment of inertia. But the way I'm reading it, like this gray seems like the same shade of gray as this. So I'm taking that as equal density and that C has greater mass. That's why I'm saying A. But it seems vague on that front. Admiring Outdoors, you just solved Anime Weeb's question for the numerator. The rest is easy integration. Oh, it's the song. Oh, it's something in my eye. That's E? Bruh. Oh my god. Yeah, the person posted it. I'll put it in the thread. But the person also posted it in the Discord. Okay. Integer paired with accelerated center mass down the slope. Also to get the disk rotating. Yes. And so the debate is whether they have equal mass. To be honest, I think if they have equal mass, C is the answer. But the way I'm reading it, C has greater mass than A, so I'm saying A. But I feel like the question is vague on that. Ball rolls without slowing down a plane inclined at angle theta. Friction force from the plane of the ball. Okay, so what is friction doing here for number 8? Yeah, anyway, I'm glad that other people are able to figure that out. Um, so what friction is doing for us is basically at any instantaneous point in time, the ball wants to slip and just like slide down the slope, but friction is pulling it back that way. Total mass that doesn't matter. Really? Oh, awesome. Anime weed. The density only depends on the radius. That really doesn't make sense to me, to be honest. I know, if I'm wrong, I'm wrong, but so friction does seem to be agreeing with the direction of rotation. Which would lead me to believe that it's making the ball rotate faster. That feels like it can't be right, though. Can it? No, it can't be right. Because a ball rotating on a flat plane with friction will eventually stop. Hey, Nikhil. Oh, do you want to talk about polar complex numbers? It must make omega decrease, but that this does feel weird. Like I don't know how to. Hey, Asta? Like I think the flat plane thing that I said shouldn't be fundamentally any different from an inclined plane. Like friction should be stopping this ball from rolling, but I don't quite get why. Or I can't like I feel like I'm contradicting myself when I'm saying over here where friction looks like it's making it go faster. I think the answer should be D. Wait, G sine theta. Maybe it could be bigger than g sine theta. Because g sine theta would be 0 in the flat plane case. Is that why? Is that the important difference? So maybe it does make it increase. Saying B? But if omega is increasing, isn't ACM bigger? I thought B didn't make sense. Or wait, is G sine theta... Wait. Oh, G sine theta is tangent. Oh my, I always get this mixed up for inclined planes. Is G sine theta along or normal? How do you draw this triangle to figure that out? Is it that? No. Parallel to the plane? Okay. Causes omega to increase because it provides torque. Interesting. Hey, ND Vines. I don't know chemistry, I'm sorry. G sine theta is parallel. Okay. I think I see why it would make ACM smaller than G sine theta, because G sine theta is pointing like that and friction is opposing that. Maybe I don't think about it harder. That's the chem question. Oh, and then there's another chem question. I can't do chemistry, but we're gonna check the answers on these now. I don't think did I check it? I don't remember what I checked the answer for or not. 7.5 is C. Got that right. 7.6 is B, which I got wrong. .7 is C. .8 is B. Okay, what's the deal with these? I'll copy that over to ND Vines. Thank you, Jasu. I'll copy over Crim's thing too. Wait, so what was number 6 asking? Nikhil, I don't think I know what to do that one. I'm sorry. Oh, Obi over on the YouTube side. Dude, it was so funny to go back and rewatch that video of the math streamer meeting from when like a lot of us first met each other. It was just a throwback. Hope you're doing well. Ice cream, thank you. Yeah, to be honest, Obi, I didn't realize you weren't like aware of that, but there, you know, we never like specifically like went out there and advertised it afterward, I guess. But yeah, I imagine that might help explain some things. I don't know. Nikhil, I don't know how to do that. I'm sorry. Um, oh, that's true. You could try actual education because he does stream on YouTube also. B-Tech related questions? I never heard of B-Tech. Is the YT math command gonna work at any point? Uh, oh, good. I got disconnected. Dude, YouTube keeps booting me from my bot. It's so annoying. Okay. That command isn't gonna work. Let me. I will be the bot. Yeah, I really wish that there was some chemistry streams on Twitch. Seems like a thing that people have questions about. Oh, thank you, Ahmed Blam. I turned it up because there's a good song playing, and I forgot to turn it back down. But hey, it hasn't been choppy at all, or at least no one's complained about that. Which is that means maybe the Windows update actually fixed it. Hope you're doing well, Ahmed Blam. Um, oh, I think I see why. I just was visualizing number 6 wrong, I think. Friction is keeping the ball in place on the rug. And since the rug is moving to the right, the ball will get dragged to the right. But for some, I guess like inertia reason or something like that, it is going to rotate the other way. Okay, I think I can see why I was wrong for 6. Um, for 7, what are they saying? Wait, so are they saying the mass is all the same? I don't get it. Like the total mass is the same for all of these? They need to say that. I don't know. Dude, that just doesn't make any sense. The mass doesn't actually matter. Why? Man, this is some classic Morin stuff. So like counterintuitive. Ugh. Yeah, Femlux was right. It's just annoying that the distribution of mass matters, but the actual quantity doesn't, apparently. I really hate that. Non-Euclidean geometry, I'm learning a little bit about differential geometry. All right, and then for 8, the answer was B. Friction provides torque. Okay. Because the moment of inertia is the sum of r squared times bm. But something with more total mass has more moment of inertia, doesn't it? That's what I don't get. Nikhil, that integral looks terrible. I'll put it in dual from alpha and see how terrible it really is. But this is potentially a very, very long integral. Step 1, compute the integral. Yeah. Um... You can Sarthak, yeah. Nikhil, I'm trying to understand it. That I don't know yet is the answer. I think you need to multiply out the numerator and do long division. So I'm not going to do this by hand. You remember solving this, Krim? Yeah. It's very ugly. I'm gonna have Wolfram Alpha multiply out the numerator for me. Yeah, that makes sense, Krim. Okay, so you need to multiply out the numerator, which I'm not doing that by hand. Wolfram Alpha will tell us the answer though. Then you need to do division with this, synthetic or long division. I know long division better, so I'm going to use that. Actually, I'm not going to do that by hand either. That's going to take such a long time. I'll show you how to set it up, but actually doing this is also this problem just takes a long time, and I really don't feel like doing every step here. You also need plus 0x cubed plus 0x squared plus 0x plus 0. So, I mean, could you leave the x to the fourth out front and bring it in at the end? That's probably better. You can save yourself a little bit of work. Shifting it by a half might help. Maybe I don't see it though. I'm also getting tired, so there's a lot that I don't see. Okay, I'm gonna have a new plan. I'm gonna put the x to the fourth out front here, and only multiply out the 1 minus x to the fourth. I think this is marginally less work because the long division is a little bit simpler here. So that's long division you would set up, where you can do synthetic division if you know that. Oh, funny, Krim. Yeah, the answer was kind of funny. So yeah, go through with that long division. I'm gonna have Wolfram Alpha do it. Oh, what? Wait, what? Oh no! I'm looking at the wrong result. What you get from the long division, x to the fourth times x squared minus 4x plus 5 minus 4 over x squared plus 1 dx. U equals x minus a half simplifies it? Really? Um, guess let's investigate it. I forgot my use. I don't know. I don't see how this is simpler. Yeah, we don't quite get an arctan directly because there's a gimme next to the fourth there. There was an arctan in the final answers somewhere. I don't know how you do the... When you get the x to the fourth there, I don't know how you do that integral, to be honest. Yeah, I don't quite know what you do after that U sub. Maybe it's a thing, though. Oh, I messed that up. You're right. $10. Uh... I don't know. Ugh. I think I can do that, Sarthak. Just let me... You'll be right after this, and you're gonna be the last one of the day. Yeah, maybe there's something with that sub, but I don't see it, and that could just be my own tired brain. Nikhil, this integral is just too big for me to really do it. I'm sorry, but what you do is you multiply in the x to the fourth here. And I think you can deal with this integral by taking u equal to x squared plus 1. No. You have to divide it again. That's what you have to do, I think. Plus 1 minus 1? I mean, I can see with the minus 1 you get the difference of squares, I guess. I guess so. If you do a minus 1 plus 1 thing in the numerator, the x to the fourth minus 1 is the difference of two squares. And so I'm just looking only at that piece for now. X squared plus 1. X squared minus 1 over x squared plus 1. Oh, okay, so not 4. Okay, so the x squared plus 1 will cancel. Okay, so yeah, that is a lot simpler. So if you do the -1 plus something, you get a nice cancellation. And then the integral becomes easy because these are all just polynomials, and that's arctan. And I'm getting tired, so I'm not going to do it any further. But that's the technique for what you do for that integral. Uh, this is from Sarthak. Okay, so what I'm going to do is I'm going to reorient this a little bit to make the calculations simpler. Because I want to put some coordinates on this. So x and y, I'm going to make OA go along the positive x-axis. So I'm going to say this is O at the origin. This is A at the end. This is B with a 120-degree angle. Below, that just depends on the person. Study until you feel like you get it, basically. It's not really a universal answer. We're traveling along OA at 4 km per hour. Traveling towards B at 3 km per hour. So for OA, at any time t, our position is 4 times t, comma 0. For OB, yeah, and integration isn't easy to learn. Instead of 120 degrees, I'm going to worry about the complementary 60-degree angle here. And this is the other sum. So the x-coordinate is going to be -3 cosine 60. The y component will be +3 sine 60. And we can calculate that. Cosine 60, 1/2. I'm sorry, t. T. So -3/2t. That's going to be √3/2. So 3√3/2t. And so the shortest distance is given by the distance formula. D is equal to root, I don't want to put the parentheses, x2 minus x1 squared plus y2 minus y1 squared. So these are functions, but we sure as hell can plug them in. This is still x, that's still y. It's going to be a function of time, and that's perfect. We can save ourselves some work here. We can optimize distance squared, and it's the same thing. Basically, just chop off the square root. This is a common trick with optimizing distances, and you get the same answer. So for t minus -3/2t squared plus 0 minus 3/2t squared. Now we simplify this, take the derivative, and plug in t equals 1 is the path. 148 divided by 4? 37? Do my eyes betray me? It sure is. Oh, yeah, actually, I should... The squared thing isn't good, is it? We can take the square root now. I probably should have just never gotten rid of the square root. It doesn't actually work here, but we just take the square root from where I left off and get here. I'm getting 2 root 37, I think. So we want the rate. So we're going to take the derivative with respect to t. 2 root 37t. And then they're asking about t equals 1. So the derivative evaluated at t equals 1. I'm getting 2 root 37. Think it was a bust? No worries. Oh, you're right, Krim. Thank you. I didn't take the square root. So yeah, I'm getting root 37 Sarthak. No, I mean, I think it's a... That does help with some integrals. It's not a bad thought, Fembox. So yeah, the real tricky bit here is figuring out these equations and then plugging them into the distance formula. Or like, you know, and figure out like how to work with that. But once you do that, it's kind of just following through. Okay, I think I gotta wrap it up though. I'm tired. Oh yeah, sure. Computer guy. While you're doing that though, I am gonna cut off the YouTube stream. So notice here on YouTube. Actually, well, no, the YouTube can hear the joke. What do you call two friends who love math? What? Algebros? Oh my god. All right. On that note, Algebros. I'll see you later at Algebros on YouTube. On Twitch, we're gonna look for a raid.